To follow a patient over the time, we can record the mean deviation, and we have this curve, and then we draw a line and see the slope of this line, and accordingly we would say that this patient is deteriorating in that rate, fast or slow or whatever, and we get these numbers here. So do you know what is the meaning of these numbers? Again, in the new visual field index, this is the record over the time, and this is the line, and this is what's expected in the next 5 years, and this is what's written here. The rate of progression is 3.7%, but written here plus minus another value, and this is the 95 confidence interval. So do you know what's meant by that? This is a very important clue to tell us that whether this is significant or not. Sometimes it's written here, it's significant, this is quite fine, but sometimes it's not written, and we need to depend on this value to evaluate the regression. So to understand this, let's go to the slope of regression line and the 95% confident interval. What is the slope? If you have some line changing, if this is the time and this is the value, and as we go over the time the value will be less, then the slope is this value divided by this value. So in our example here, it's -3 because the line is down, divided by 4. So this is the slope. In this example, it is 15 divided by 3. So this is the value written here. The slope, it's written, it is going down, so it's minus. And the rate of slope, the drop, is 3.7. Now, what is the confidence interval 95%? Means that we are sure that this value is correct, and our confidence in this belief is 95%. Let's understand what is that. Suppose we have a group, we have a sample out of a population. Suppose we have a population, 1 million person, and we record the height of this 1 million person, and we want to know what is the mean of the population and what is the standard deviation. To know that, we need to measure every single person in this group and have this curve. This is practically difficult to do and very costly. So we take a sample out of this huge number, say 100 persons. And for this 100 persons, we have the frequency distribution curve, and we can calculate the mean and standard deviation. But we are not sure how much this mean represent the mean of the population. We suggest that this mean represent the mean of the population, but we are not sure. We need to be sure, or to have a certain interval. We say most probably it is in that range. Let's understand this. Suppose we get another sample, a third sample, fourth sample, fifth sample, and so on, and then we start to get the mean of each sample and use all these means to make a new frequency distribution curve. So now we have a frequency distribution curve of the means of the 5 or 6 or 7 samples we took out of this population. Now this frequency distribution curve of the means, we can calculate its mean and its standard deviation. The standard deviation of these means is known as the standard error. We can use the standard error of the means to calculate the confidence interval. Suppose this is the population and this is the mean of the population that we don't know. And this is the sample and this is the mean of the sample. Now the standard deviation we calculated here, if we go 2 standard deviation up, 2 standard deviation down, then this is the 95% interval. We are sure that the real unknown mean of the population is located inside the 95% interval of the mean of the sample. Suppose we get another sample, and this is the 95% of interval. This is the mean of the new sample, and the population mean is located inside this 95%. And the same if we repeat the sample so many times. So statistician can calculate this. For example, if we doing the regression line over the time we've seen before, suppose we measure the field at 1 year, 2nd year, 3rd year, 4th year, 6th year. We may have these readings. This is one reading, we repeat it, this will be. On the 3rd year, this is one reading, this is the 2nd. On the 5th year, this is one reading, when we repeat it, we get this. There is another chance, if we already did the same test, we may have these 2 points here, or these 2 values can be here, or these 2 values can be localized here. Because this is by chance, you are taking a test, sometimes you get one value, sometimes you get another value, you are not sure. So the regression line in this example will be on that way, but if we change this dots, it will be another line. So when you see this, this is the line already plotted for us, and these 2 curves tell us that the line can be, if we repeat the test several times, can be any of these located in this zone. So this is the 95% confident interval. This is the actual first reading, but still if we repeat the test several times, we may have another slope. And this is the confident interval that we are sure 95% that we are within this area. For example, in the OCT, the progression, here this is the progression of the retinal fiber layer thickness over the time. You can see the slope, and this is the gray zone around it. This is the 95% interval, confidence interval. Again, this is the ganglion cell thickness over the time, and this is the zone around it. So back to the field. What's meant by what's written here? The rate of regression is minus 3.7. The confidence interval, it can be something between plus or minus 2.7. That's to say, the 3.7, if we add plus 2.7, we will go here, it will be minus 1. If we add minus 2.7, it will be down here to minus 6.4. So the line in this example, it is this one passing to 3.7. But if we repeat the test several times, we are confident that it can be located in any line between the minus 1 and the minus 64. This is the confident interval for our test. Okay, what we get out of this? As long as the confident interval does not include 0, we say that this is significant. But if another example that the confident interval is large like this, and it included the 0, so there is a possibility in this confident zone, 95 confident zone, that sometime or one time the regression is here is 0, so there is no slope down. So we are not sure even if our value is minus 2.2, we are not sure that this is statistically significant. This can be by chance, and if we repeat the test, we might have this zero, no slope. Then once we get this zero in the interval, then this is not significant change. So in this example, in the field, it's already written here, the 95% interval, it is between minus 0.78 down to minus 3. So 0 is not included. So we say yes, this 1.9 is statistically significant. In this example, the interval is located between minus 84 to minus 77. This is the 95 interval confidence. So the value 1.3 is, there is no zero in the confident interval. So we are sure that this drop is statistically significant. Here, in this example, again in the OCT, you see here, this is minus 1.93. If we include this fluctuation up and down, it will not reach to the zero, so we say this is significant. In this example, the slope is minus 0.19, but the fluctuation, or the 95% interval, can go to plus 3 something down to 3 something. So plus 3, this actually will include the zero, so this is not significant at all. So this is the meaning of these numbers. So the rate of regression, this is the slope, and the number we have here is the confident 95% interval, that if we repeat the test several times, we are confident that it will be located in this area. The value of that, if the zero is included in this confident zone, 95 confident zone, then this test is not significant. Thank you.